Introducing the LCD anodizing system, exclusive to Caswells. LCD anodizing, or low current density anodizing, is a cutting-edge system giving you a simple operating procedure resulting in consistent quality that will gain the envy of professional anodizers. The LCD system has a tough, hard anodized surface and can be dyed in a vibrant range of colors. It uses very dilute chemicals, so it's environmentally friendly. Because the LCD system has a special mist suppressant, an oil-like material that floats on the surface, there are no fumes, and it's therefore very safe to use. These kits are fully expandable, so can be upgraded to professional level. Many customers upgrade by using the Rubbermaid or Sterilite keeper boxes. In this photo, the customer has used 20-gallon Rubbermaid keeper boxes and insulated the sides, protecting the insulation with plastic and duct tape. Here you can see a highly magnified view of the anodized film. The film, unlike electroplating, actually grows out of the aluminum, a little like rust forming on steel. The thin tubes are transparent and the dye capillaries into them. Finally, the anodized film is sealed, locking the colour in permanently. Of course, for a natural aluminum look, you may omit the dyeing process, and after growing the film, proceed directly to sealing. Setting up the tanks. We're going to look at setting up the 5 main LCD tanks: degreaser, deoxidizer and desmut, anodizing, dyeing, and the final sealant tank. SP degreaser uses a 300-watt ceramic heater which will bring the solution to a near boil. Add the degreaser at 1 pound per 2 gallons of distilled water. SP degreaser is normally a soak-only system, so no power is required. Only use this system if the part has been buffed or immersed in oils and has failed the water break test. You should degrease before any bead blasting to avoid pounding the oil into the surface. The deoxidizer and desmut tank is an important part of the process. Add the 2 quarts of solution to the tank and then add 4 gallons of distilled water. Install a 300-watt heater and raise the temperature to 110 degrees Fahrenheit. The anodizing tank needs 3 gallons of distilled water and 2 quarts of battery acid. You should carefully measure these items out prior to adding them to the tank. Battery acid can be obtained from any Napa auto parts store. Wear a protective face shield, gloves and an apron when setting up this solution. Splashing can easily occur and this acid will burn eyes, skin and clothing. Have some baking soda on hand to neutralize any spills. Make sure you add the water to the tank first and then the acid. If you pour the acid in first followed by the water, you are likely to have a violent reaction and the mix could explode in your face. Install the GP plates. These are made of a lead alloy, so wear gloves to protect yourself. Cut a 1-inch strip down the side of each plate, but don't sever it. These will be used to make the connection to the power supply. Bend the ends of the tank bar over to fit the tank top and drill a few holes in it for the hanging wires. The anodized mist suppressant is an important part of the system, ensuring your protection from any fumes or acid mist that would otherwise emit from the tank. Add 2 teaspoonfuls of mist suppressant per 3 gallons of distilled water and replenish if you smell acid. Using a permanent marker or scribe point, make a mark on the waterline. You will need to top up this tank with distilled water to this point due to evaporation losses. The tank heater should be set to 72 degrees Fahrenheit. There's a small knob on the top to adjust the temperature. The filter pump is a vital part of the anodizing process. Maintaining vigorous agitation at all times will ensure quality and consistent results. The pump should be removed from the solution and thoroughly disassembled, rinsed and dried after every operation. Impeller and shaft wear is normal, and these should be replaced periodically. The small black bulb and air tube should be fixed so the bulb is out of the solution. This allows air to be sucked into the flow, causing more agitation. It also keeps the liquid cooler. The dramatic difference between just liquid flow and air and liquid is easily seen by blocking off the air intake. The anodized dye concentrate comes in a liquid form and is pre-measured to make 2 gallons. Place 2 gallons of distilled water into a suitable plastic tank and add the 1 unit of dye. Each anodizing kit is supplied with a color wheel. Dyes can be mixed together to create a host of different colors. We suggest that you make up the colors to the correct dilution first, then take a quantity of each dye and blend them together. The dye needs to be heated to 140 degrees Fahrenheit with the ceramic heater. Don't get the liquid any hotter, otherwise you may prematurely start the sealing process. The thermostat supplied with the kit will operate to this temperature. The black temperature sensor bulb should be placed in the dye tank. A result of incorrect dye temperature can be seen here, as the dye has not penetrated sufficiently and can be rubbed off. Red dyes are particularly prone to this. To make up the sealant tank, add the required amount of distilled water to the tank and then add 1 ounce of sealant for every gallon of water. Add the mist suppressant balls. These act as insulators and help hold in valuable heat. The solution needs to be brought to a virtual boil, and several factors influence the temperature. You need to do a dummy run and check temperature prior to an actual sealing job. If it's cold in your shop, you may need to add more heaters and wrap the sides of the tank in bubble wrap. Cut a small slot in the lip of the tank to allow the heater wires to exit. The lid will then fit properly, ensuring less heat escapes. The power supply is connected to the GP plates and the tank bar, which hold the part being anodized. Let's strip this diagram down to the wiring to get a better view of the setup. The red or positive wire is connected to the tank bar and the part being anodized. The blue or negative wire is connected to both the lead GP plates. As the anodizing process progresses, the film becomes thicker. This film, unlike electroplating, is an insulator, and the thicker it becomes, the greater the insulating properties. This means that the current has to be continually increased to overcome this to produce a consistent result. Constant current power supplies carry out this function automatically. Here is a constant current 20 amp power supply. This unit will anodize a maximum of 1000 square inches at 0.02 amps per square inch. There are 2 controls for the voltage, fine and coarse. With the unit switched off, they should be turned fully clockwise. Similarly, there are 2 controls for the current. They should be turned fully anti-clockwise. Then the power should be switched on and the current indicator should light. The unit is then fine-tuned using the 2 current control knobs to dial in the required setting. The 3 amp constant current power supply is adjusted in a similar fashion, except there are no fine-tuned controls. This unit will anodize a maximum of 150 square inches at 0.02 amps per square inch, or 75 inches at 0.04 amps per square inch. The actual power requirements are very simple. You need 1 amp for every 50 square inches of surface area for 240 minutes, or 1 amp per 25 square inches of surface area for 120 minutes to grow the required 1/1000th of an inch anodized film. However, for dyeing and light surface work, you can cut the times by 25%, giving you a thickness of 3/4 of a thou. The most important part of the LCD anodizing process is the surface preparation. Poor surface preparation will show up immediately if dyeing the part, as the dye will look patchy. Even fingerprints will cause major problems. Many old aluminum parts are often either painted or covered in oxide, and these must be removed to expose the bare metal. Old paint, including baked-on powder coating, is easily removed using VHT paint stripper. It's sprayed on and usually works in seconds. This is the least invasive treatment for the base metal. Oxide layers are best removed by fine abrasive or bead blasting. Different abrasives will give different finishes, and we suggest you experiment with these. The Caswell scrubber wheel will also work well when sandblasting equipment isn't available. It has the disadvantage of not being able to get into nooks and crannies. A smooth satin finish is the ideal base for dyed anodize. This finish is very easy to achieve using bead blasting or the scrubber wheel. However, by buffing the aluminum, the anodized part will have a shinier look to it. Of course, if you do this, you will need to use the SP degreaser to remove the buffing compound. This device is ideal for all anodizers, as it solves the problem of poor connections by physically welding the hanging wire to the workpiece. Poor connections are the major cause of failed jobs. Wear dark glasses when spot welding. The flash is like an arc welder. Let's see that again. When the power light is plugged in, the on light will come on. Seconds later, the half power light will come on. At this time, you may be able to weld thinner wires. By turning the knob clockwise, you will bring the unit to full power. This setting is only needed for the thicker wires. The unit will also weld copper wire to copper and steel wire to steel. After carrying out the surface preparation, the part needs to be degreased. Immerse the part in the SP degreaser, ideally operating the solution at temperatures higher than 140 degrees Fahrenheit. Sometimes you may need to use a small brush like a toothbrush to remove caked-on buffing compounds. Do not handle the parts with your bare hands after this point. Insert any plugs to protect threads, etc. Rinse the part with distilled water over the degreaser tank. Carry out the water break test. Immerse the part in the deoxidizer de-smut solution for 3 minutes. Rinse the part in distilled water over the deox tank. Hang the parts into the anodizing tank and switch on the power supply. Set a timer as a reminder. Rinse in distilled water over the anodizing tank. If you don't need to dye the part, proceed immediately to the sealing tank. The dye should be operated at 140 degrees Fahrenheit. Carry out whatever masking is required, then immerse in the dye tank for up to 15 minutes. Rinse in distilled water over the dye tank. Remove any masket. And finally, immerse the part in the sealant tank and seal for 15 to 20 minutes. Rinse in distilled water over the sealant tank. It's a good idea to keep a record of the time and the surface area for each job, because after 100 square feet at 1 ml of anodize, your solution will need to be replaced. The fade dye technique, once mastered, can produce some incredible effects. The most economic way to accomplish a fade is to use 2 tanks and siphon the liquid from one into the other. This provides a fade with no lines, unlike hand dipping the item. Controls can be introduced by watering down the dye and altering the flow by changing the pipe diameter. You will need to do several practice runs to become accomplished at this. Set a piece of aluminum wire into the tube to stiffen it. This will ensure the end of the tube reaches the bottom of the higher tank. You should also wire the tube to the tank to ensure it does not fall out and interrupt the flow. A loop in the tube is a good idea, as this allows you to watch the liquid enter without getting a mouthful. A few dollars invested in a simple fuel tank siphon may save you having dyed teeth. In this example, note how quickly the dye takes. We used a large pipe with dye at full concentration and achieved a very slight fade. To lengthen the fade, you may need to weaken the dye and speed up the dye flow. One customer, doing a lot of fade dyeing, made this large Cammon motor to produce an even faded dye effect. The motor speed could be altered to change the effect. Note how even the fade is. This dipping technique can be done by hand, but it does need a little practice to get a fade with no lines in it. To fade 2 colors together, as in this example, just hang the part from the opposite end when dyeing, so the pale parts of the fade overlap. Anodizing, like electroplating, adds dimension to the part, but unlike plating, an anodized film grows over all areas exposed to the liquid. This means it is especially important to block off any areas that have critical dimensions. Threaded holes can be especially bothersome. A thread with an additional 1/1000th of an inch added to it will not accept a bolt. Plugs are a great way to solve this problem, and they come in a huge variety of shapes and sizes. Where tight-fitting components are a sliding fit, the anodize must not be allowed to grow. These areas can also be painted with masket, a rubberized coating that will withstand the dyeing process. After anodizing, the masket is applied using a paintbrush. It's best to apply 2 coats, leaving 15 minutes between coats, and a final drying time of at least 1 hour. Designs can be cut into the coating using an X-Acto knife. The unwanted layers were peeled away prior to dyeing. In this example, the part was initially dyed red, then the masket applied and cut away. The upper area was peeled off and a fade bleach technique applied to remove the red dye. This example shows how the girl's silhouette was left masked and the outside masket removed before dyeing.